Hey guys, here we are going to solve some of the questions related to the past papers of paper chromatography and to the past papers of kinetic particle theory. Let's solve one of the questions. It is one of the theory paper of 0620 and 42 and it is February-March 2018. It is written at the bottom of the same page. Okay, so I am just spotlighting the thing. Chromatography can be used to identify simple sugars in a mixture. A student analyzed a mixture of simple sugars by chromatography. All the simple sugars in a mixture were colorless. Okay, so what is the name given to the type of the substance used to identify the positions of the simple sugars on the chromatogram? So they are saying it is colorless. So what we will write over there, locating agent will be a substance which will be used to spot this thing out, that where are the different spots of the sugar. Okay, so the student calculated the RF value of a spot on a chromatogram. Complete the expression for the RF value of the spot. Okay, so what we are going to write here, it is RF value is equal to distance traveled by distance traveled by spot divided by distance traveled by solvent. Okay, traveled by solvent. Okay, now how could a student identify a simple sugar from its RF value? Okay, so if RF value of the two sugars will be similar, it will tell you that this sugar, this simple sugar is present in that specific sample. Okay, so by coinciding, by matching the values of RF value, so by relating the RF value results in this way, if RF value is same, it can tell that simple sugar is present in that compound, in that sample. Okay, so sometimes not all the substances in a mixture can be identified from the chromatogram produced. Explain why this may happen. Sometimes, look at here right now, what is the meaning of question number 4? I am telling it to you here. Okay, so this is, for example, the paper on which chromatography is performed, and this is the simple line over there with this, which is drawn with the help of a pencil, and this is called as a start line or the baseline, which is there in the experiment. So here we have placed a spot of sugar here. Okay, and it is converting itself into, it has been said to us that it is converting it will convert itself into 4 spots. Okay, it will convert itself into 4 simple sugar. Let's see. Okay, so 1 is there and 2 is there and 3 is there. Okay, so we can say this thing that the spots have traveled the distance, but we can definitely say this thing that out of the 4, 3 are there. Where is the fourth one? So it means that 2 of the spots have traveled the same distance. 2 of the samples, 2 of the parts of the sugars have traveled the same distance. We may say this thing that 2 parts have the same RF value. That's why they are superimposing each other. That's why coinciding each other. That's why they are over each other. Hence, this is the reason that's why we are finding this thing out like this. Okay, so it is part of one of the question. E part was there and I have taken only that part to solve the topic of chromatography here. Okay, now I'm going to share one more question with you related to these chapters. Okay, this is not, and this, yes, this maybe, yes. Okay, so here there is a question of year 2020 and October, November, and it is the variant to 1. Okay, this question is about halogens and halogens compounds. Halogens are the elements of group number 7 in the periodic table: fluorine, chlorine, bromine, iodine, and astatine. A drop of bromine liquid was placed in a sealed glass jar. After a time, the color of bromine had spread throughout the jar. Explain this observation in terms of kinetic particle theory. 3 marks, 1, 2, 3, 4, 5 lines for this. So it means that we have to explain each thing in detail. Okay, before moving ahead, I would like to inform all of you that not only bromine, rather nitrogen dioxide, both of them are dark red brown in color. Okay, nitrogen dioxide has formula NO2, whereas bromine has formula Br2. I'm writing the formula of bromine as well. It is not called bromine, it is bromine. So this is bromine, Br2. Okay, and this one more thing I'm telling you, red brown is the color. Okay, they are not mentioning that, they are just saying the color of the bromine is spreading. Okay, they are not mentioning the color. So what is the observation? So we can can say this thing that according to kinetic particle theory, okay, I am going to write the answer here. According to kinetic particle theory, particles move from an area of higher concentration to lower to an area of lower concentration. This is diffusion, na? But you should know this thing that diffusion is based upon the fact of kinetic particle theory. Okay, diffusion is one of the application of kinetic particle theory, basically. Okay, so that's why what we have written according to kinetic particle theory, comma, particles move from an area of higher concentration to an area of lower concentration. That's why you may continue in these two lines. That's why particles of bromine will start spreading from one side to the whole area available in the jar. Okay, now they are asking about B part 1 and 2, which is not part of your syllabus currently, and B part 3, which is about the chlorine to make other chemicals. State one other use of chlorine. It is also not part of your current syllabus, but I can tell it to you that chlorine is used to kill germs. Chlorine is used as a disinfectant for water. It is used in water treatment. You may write for water treatment to kill the germs. Okay, I am solving one more question, and this is this question. All right, I'm reading the question. Glass waste is melted and then made into new objects. All right. Use the kinetic particle theory to describe the changes in movement and arrangement of the particles when solid becomes liquid. All right. Solid becomes liquid. What was that process? I have taught you earlier that solid turning itself into a liquid is called melting. Solid absorbs heat and then it will turn itself into a liquid state. So what we are going to write for these 2 marks and 5 lines. So here we should mention the heat, here we should mention kinetic energy, here we should mention this thing that particles are moving away from each other and what is happening. So I am just writing this that by increasing temperature of a solid, particles of solid will gain kinetic energy, hence will start moving with higher speed and forces of attraction will break up, full stop. Particles will become apart from each other, from one another, and loose arrangement of liquid will be developed. I have soft pen, so obviously it will take a longer space, a little bit larger area to write, but you people will be able to manage it in the same lines. Okay. So, and loose arrangement of liquid will be formed, or yeah, will be developed. Okay, full stop. Okay. Then question number E is not part of your current syllabus. It is part of bonding chapter. I will teach you bonding chapter inshallah, and then I will explain that over there. So right now I am on the next question, and this is this. Yes, chromatography again. It means that examiner loves chromatography. It is a very clear idea. Okay, so paper chromatography can be used to separate a mixture of amino acids. The apparatus used is shown. There is a lid over there, chromatography paper, which is called chromatogram. Baseline is there and solvent is there. Why should the baseline be drawn in pencil and not in the ink? We have explained this thing in detail in the previous past paper session of chromatography as well, and in the lecture of chromatography as well. If what how to write for these two lines and 1 mark. uh, Pen ink is soluble in the solvent, hence the results of chromatography will be affected, or you may say very clear results of chromatography cannot be obtained as ink of pen will dissolve in the solvent. Okay, so whereas pencil will not, definitely. So when the separation of the amino acid is complete, the chromatography is separate with the locating agent. Explain why. So how to write the answer here? You may say this thing: amino acids, amino acids, comma, produced what? Colorless spots, comma, hence to shift colorless spots to colored spots, locating agent is sprayed. What was next? The diagram shows the chromatography paper after it has been sprayed with a locating agent. Okay, done. And then they are saying that it is S and this is baseline and this is. Then they are saying calculate the RF value of S. Okay, so we can discuss this, how to calculate the RF value. Okay, it is the distance traveled by S divided by the distance traveled by the solvent. Okay, I'm writing distance RF value of S is equal to distance by S divided by distance by solvent. So don't forget this thing that RF value is always lesser than 1. Why it is so? Because it is always a smaller distance divided by larger distance. Okay, so I would like to solve one more question with you people. Let's see. We have one. Yes, we have one. So here they are saying a sample of neon has a volume of 21 decimeter cube whatsoever at room temperature and pressure. The temperature of the sample is increased. Now they are saying that temperature is increased. Pressure remains constant. Describe and explain using kinetic particle theory what happens to the volume of the sample. Guys, there are two laws which I have explained you earlier. According to Charles' law, temperature is directly proportional to volume. According to the Boyle's law, pressure is inversely proportional to the volume. So when they are saying that pressure is constant, so it means that Boyle's law is not playing any role. So they are talking about temperature. So by increasing the temperature, what will happen to the volume? So what we will say here, by increasing the temperature, kinetic energy of the particles will increase. Particles will start moving with a high speed, and as a result of that, they will now occupying greater area. So what is volume? An area occupied by an object. Initially, when there was lesser temperature, particles will have greater force of attraction. But when temperature is increased, kinetic energy is increased. As a result, force of attractions are breaking and particles are occupying more surface area. Okay. So then they are saying the pressure of the sample is increased now. Temperature is constant. So it means now they are dealing with pressure. Okay. They are dealing with Boyle's law. Describe and explain using kinetic particle theory what happens to the volume of the sample here. Okay. Now we know this thing that pressure is inversely proportional to volume. So what you will say that by increasing the pressure, particles will come closer to each other. As a result, particles will occupy smaller area. You may say volume of the particles will be smaller, volume of the sample will be smaller as particles are under high pressure. Okay. Now I am going to share another. Okay, this is done. This is now. Okay. There is a question. What is meant by the term evaporation? So evaporation is shifting of the liquid into the gas before boiling point. Shifting of a sample, shifting of a liquid sample into gaseous sample before its boiling point. A sample of ethyl ethanoate, something, something. I will discuss this thing with you in organic chemistry. When I will teach you organic chemistry, inshallah, I will discuss this thing over there with you. Okay. In a beaker is moved into a colder room. Explain in terms of kinetic particle theory why this results in the decrease in the rate of evaporation. So what we will say over there, by lowering down the temperature, particles will have lesser kinetic energy. As a result, they will have lesser ability to shift themselves from the liquid state to the gaseous state. That's why by lowering down the temperature, rate of evaporation, speed of evaporation will be decreased, whereas by increasing the temperature, rate of evaporation, speed of evaporation will be increased. So temperature is directly proportional to rate of evaporation. Rate of evaporation. All right, now I am discussing with you, I guess, one more and the last question of the day. All right, so here they are saying E numbers identify chemicals which are added to food. E210 is benzoic acid. How could you show that a solution of benzoic acid is a weak acid? Guys, I will teach you the chapter of acid, bases, and salts, inshallah. At that time, I will discuss with you what is a weak acid. And then they are saying E110 is sunset yellow, some dye. Okay. Outline a method you use to show the presence of E110 in a food color. You may draw a diagram to help answer in the question. Okay, to answer the question. Okay. Sometimes the students say to me that the examiner is saying that you may, so it means that it is not compulsory to draw the diagram. But please be careful, whenever examiner is asking from you, you may draw the diagram, or if there is some space for the diagram, you people have to draw the diagram. So it means that here you can draw a diagram like this, and then it is a container like this. Okay. And instead of that, it is better to draw it like this. Okay. And then this is the level of the solvent. This is the baseline, which is drawn with the help of a pencil. This is the solvent front. This is the lid over there. And here is a spot, and here is a spot. We can say this thing that E110 is there, and E110 is sunset yellow, and it is part of the food coloring. So it is the food coloring, and it is E110. Okay, so we will just check this thing. These are the spots by food coloring, for example, and this is the spot by E110. So in your explanation, you are going to write that the spot developed by E110 on the paper chromatogram is matching with one of the spot of food coloring. So we can say this thing that E110 is present in the food coloring as the spots are coinciding with each other. So this is the way to draw the diagram, but be sure that you people should mention everything very clearly. This is the lead, this is chromatogram, this is solvent, this is solvent front, this is baseline, and here you people have to write all the explanation which I have mentioned for many times before in my lectures regarding paper chromatography. So you will write that a paper chromatogram is taken, baseline is drawn with the pencil, spots are placed with the help of a dropper or pipette, and then the paper chromatogram is immersed in food coloring gas. So it means that it is soluble in water. So you are going to place that as it is a food coloring, so definitely it will be soluble in water. So here the solvent is water. You may write here it is solvent, which is water. And then the process of chromatography is carried out after finishing of the experiment. The results are observed, and it is seen that E110 spot is coinciding with the food coloring spot, which is telling that E110 is present in that food coloring. All right. All the best, guys. Thank you very much. Take care of yourself.